In an earlier lecture, we began our discussion on angular momentum of our object, and we gave the following relationship between the net torque and the angular momentum. The net torque acting on the object is equal to the derivative of the angular momentum function with respect to time. So dl divided by dt is equal to the net torque acting on that point particle. Now earlier we stated that this equation is true, but we haven't actually proven it. In this lecture we're going to show that this claim is in fact true. So let's begin by making several assumptions. Let's suppose that we have a point particle mass m that is traveling along the xy plane. Now we have two important vectors that we have to take into consideration. Let's suppose that the linear momentum vector is given by p and the displacement vector is given by r with respect to the origin. Now the angle between the p vector and the r vector is given by theta. If we want to find the angular momentum of the object, we have to use the following equation. We take the cross product of our r vector cross p vector. And to find the magnitude, we said that we simply take the product of the magnitude of the r vector and the magnitude of the p vector and multiply by the sine of the angle theta between our two vectors. Now we want to actually find the relationship between the net torque acting on our object and the angular momentum of our point particle. So before we begin, let's review the following properties of cross product. So if we have a vector A and we have a vector B, and we take the derivative of the cross product of vector A and B, we get the following result. So this is equivalent to the derivative of our vector A cross vector B plus the derivative of the vector B cross vector A. And if we take the vector A or the vector B and take the cross product of itself, for example A cross A, that will give us 0. And that makes sense because the magnitude of this quantity, sine of the angle 0, is 0. So the entire term becomes 0. Now, let's actually show that this equation is actually true, and let's begin with the following relationship. So we take this equation and take the derivative of both sides with respect to time. So dl divided by dt is equal to d cross product r cross p. So notice now we use property number 2 and we get the following result. So now we take the first term and we place it here, and notice that dr with respect to time is equal to the velocity. In other words, the derivative of our displacement function with respect to time is simply equivalent to velocity. And v cross mv is the same thing as saying v cross v multiplied by the scalar quantity m. Now notice, according to property 1, property I, v cross v is simply 0. So that means m times 0 is 0, and this entire term becomes 0. So the derivative of the angular momentum function with respect to time is equal to 0 plus this entire term. But notice what dp with respect to dt is. We said that whenever an object is translating, we can calculate the net force acting on that object by taking the derivative of our momentum function with respect to time. So this entire term becomes the net force acting on the object. And notice that force cross our lever arm gives us the torque. So this entire quantity is actually the net torque. So we see that the derivative of our angular momentum function L with respect to time is equal to the net torque acting on the object, and this concludes our proof.